Writing net ionic equations. Balance the reaction if needed, assign oxidation numbers, write the oxidation and reduction half reactions, and then write the net ionic equation. So the first thing I'm going to do here is look to see if I need to balance my equation. So I have 1 Al here, 1 Al here, 1 cobalt, 3 chlorines, and 3 chlorines. So looks like I don't need to balance this thing, so that's good. The second step is to assign oxidation numbers. So if I start with my Al, I know that any element by itself has an overall oxidation number of 0. If I uncrisscross this 3, the cobalt has to be plus 3. The chlorine is going to be minus 1 because minus 1 times 3 gives me negative 3, and that will make the whole thing equal 0 with the plus 3 and the minus 3. The Al will have a charge of plus 3, the Cl will have a charge of negative 1, and the cobalt by itself will have a charge of 0. Then I need to see, well, what elements are changing as we go from reactants to products. So I can see that the Al is going from 0 to plus 3, and the cobalt is going from plus 3 to 0. So those are my elements that are going to be involved in my oxidation and reduction half reactions. The next step is to say, alright, well, what's being oxidized? The Al is going from 0 to plus 3. My oxidation numbers are becoming more positive. Therefore, I'm losing electrons, which is basically the definition of oxidation. So I'm going to write Al0 goes to Al plus 3, and I'm going to lose 3 electrons. At the same time, the cobalt is going from plus 3 to 0. That means it's gaining electrons, which is the definition of reduction. So CO plus 3 is going to gain a certain number of electrons to become CO0. And in this case, we're going to gain 3 electrons. So the number of electrons lost equals the number of electrons gained, which is convenient for us. Then I'm going to put my little stair step in, and I'm going to cancel my electrons, and ultimately I'm going to write my balanced net ionic equation. Now the final question is, what was the spectator ion? And remember, the spectator ion is the ion that does not change charge as you go from reactants to products. So if you look at this and you say, well, chlorine on the reactant side was minus 1, and it's the same on the product side, so therefore chlorine minus 1 must be my spectator ion. You are correct. Finally, the last thing that we're going to do is write the balanced net ionic equation, not including the spectator. That's key. We're not going to include the spectator, so I'm going to write Al0 plus CO plus 3 yields Al plus 3 plus CO0. And as a result, I have written a balanced net ionic equation.